This is the Pacific Heron, a ship purpose-built to transport nuclear materials between Europe and Japan, a distance of almost 18,000 miles. She is part of the Pacific Nuclear Transport Limited Fleet, PNTL, the most experienced company in the world for transporting this type of cargo. Nuclear power is used widely across the world to generate affordable and reliable electricity. Electricity that lights and powers our world today. Electricity that is essential for providing our basic and not so basic needs. Nuclear power stations produce large amounts of constant power without emitting carbon dioxide and other noxious gases. This means they make a big contribution to global policies designed to reduce air pollution and limit climate change. PNTL helps make nuclear power more efficient by making it possible for electric utilities in Japan to recycle their used nuclear fuel in Europe. Japan, like many developed countries, has a well-established nuclear energy industry and is committed to a strategy of producing secure supplies of electricity to serve its towns, cities and industries. To support this strategy, Japan has adopted the nuclear fuel cycle. This involves reprocessing the used nuclear fuel, conditioning and storing nuclear waste, and recycling the valuable energy-rich materials which can be used for further electricity generation in nuclear power stations. After nuclear fuel has been in a reactor for 3 to 4 years, it needs to be replaced. But this used fuel still contains a considerable amount of unused energy. Extracting this is achieved by chemical reprocessing in large complexes in England and France. A new complex has now also been built in Japan. A large proportion of the used fuel can be recovered in this way and used to make new fuel.
Japan's nuclear recycling policy has 3 objectives. One is to make more efficient use of limited uranium resources. Second is to reduce the generation of radioactive waste as much as possible. And third is to realize a stable supply of energy from nuclear power.
Reprocessing used nuclear fuel recovers 97% of valuable reusable materials and separates out the remaining 3%, which is waste. These recycling operations take place in facilities owned by the United Kingdom's Nuclear Decommissioning Authority, or NDA, and France's Areva. PNTL is owned by the NDA through its subsidiary company International Nuclear Services Limited, Areva, and Japanese electric utilities represented by the Overseas Reprocessing Committee, or ORC. The NDA and Areva have extensive experience in safely managing radioactive materials. The reusable materials are uranium and plutonium. Mixed oxide fuel, or MOX for short, is manufactured from a blend of uranium and small quantities of plutonium. As with other types of nuclear fuel, the manufacturing process first involves making small pellets, which are placed inside zirconium alloy tubes. A series of these tubes together make up a fuel assembly, which is transported to a nuclear reactor to generate electricity. Just one tiny pellet of MOX fuel, weighing about 6 grams, has the energy equivalent of a ton of coal. Each fuel assembly produces enough electricity to supply 30,000 families for a year. MOX fuel has been loaded in nuclear reactors since the 1980s. Today, over 30 nuclear power stations are powered with MOX in France, Belgium, Germany, Switzerland, and the United States. In the future, MOX use is forecast to grow significantly, particularly in Europe and Japan. Using MOX fuel means we can maximize the energy output from natural uranium ore, which is first mined like coal or iron ore before being processed into nuclear fuel. By reprocessing used nuclear fuel, we, in effect, are creating a new source of electricity. Hazardous materials have been transported for hundreds of years. But since nuclear power stations only started to operate in the last 50 years, nuclear materials have only been transported on a commercial scale since the 1960s. This has allowed international regulators to develop stringent safety standards that have ensured that millions of transports have taken place safely around the world. Under these regulations, the safety of nuclear materials is maintained by the package in which it is transported. This is the same whichever mode of transport is being used: truck, ship, train or plane. For the most radioactive cargoes, this means that the material is moved in massive casks constructed from forged steel. Each cask design has to demonstrate that it can maintain integrity under extreme conditions established by the International Atomic Energy Agency, a United Nations body with 145 member states. The IAEA tests are sequential. Surviving a drop test from 9 meters onto an unyielding surface and another onto a steel spike. Withstanding an all-engulfing fire of 800 degrees Celsius for 30 minutes. And an immersion test in up to 200 meters of water. These tests simulate extreme circumstances. Real-life demonstrations have shown just how tough these packages are. In England, a train was crashed into a cask at 100 miles per hour. The train was completely destroyed, but the cask survived. Packages have been dropped from hundreds of feet with the same results. And they have been driven at high speed into solid concrete structures. They can also withstand greater depths of water. The PNTL vessels which transport the casks are purpose-built and have a range of safety features far in excess of those found on conventional cargo vessels. Each ship has a double hull and extensive collision reinforcement. The ships have 2 engines, propellers and rudders, 2 electrical, cargo monitoring and cooling systems, and dual navigation and communication systems. Every ship also has extensive fire detection and firefighting systems. If necessary, any hold can be deliberately flooded. The vessels could even maintain buoyancy if every hold was full of seawater.
PNTL operate a fleet of fairly unique ships, and the collision-resistant structure around the cargo carrying compartment means that they're effectively ships within ships and meet the highest safety rating of the International Maritime Organization, which is the agency that regulates shipping. It means they're amongst the safest ships that sail the seas. All of our ships carry the most modern satellite navigation, weather routing and tracking equipment, and the ship's position is monitored at every stage of the voyage. All our ships are manned by a highly trained crew, and if a ship were to encounter difficulty, a trained and fully equipped PNTL emergency team is on 24-hour standby to offer assistance. All emergency arrangements are in keeping with IAEA recommendations.
The Pacific Heron is the first of a new generation of PNTL vessels. She has been specially built to transport MOX fuel from Europe to Japan. The cargo is carefully protected by a series of physical protection measures. 2 PNTL ships travel together, each providing mutual protection, although only one ship may be carrying MOX fuel. Both ships carry a complement of officers from the United Kingdom Civil Nuclear Constabulary, the armed police force which protects UK nuclear sites. Both ships have fixed armaments, advanced detection systems, secure communications, and a range of other security measures which are not visible from the outside. In 2006, New Zealand academic Dr. Ron Smith analysed the physical protection systems used for MOX shipments after being given special access to the ships and personnel involved.
I'd tried to envisage all the threats there might be. These ships are extremely well protected. I've reviewed quite extensively the systems on the ships and the methods that are used. Really, one can't imagine merchant ships being better protected than this. The public can have, in my view, confidence in the security provisions that are being made for these shipments. And when you think of all the risks, both collectively and individually, that we face, this is one which is really extraordinarily small.
Every shipment of MOX fuel is carried out under the most rigorous safety and security arrangements and includes comprehensive emergency and contingency plans which can be initiated with immediate effect. By adopting a safety in-depth approach, where the material is protected by a series of independent barriers encompassing its passive and solid characteristics, the massive transport casks and the reinforced double hulls, potential hazards are carefully managed. These safety features also provide considerable physical protection for the cargoes. All this is backed up by comprehensive training, regular emergency exercises, and a local stakeholder forum, the Ramsden Dock Terminal Stakeholder Group. This watchdog group contains local government officials and emergency service officers and provides community input into shipping operations.
I think what's really important when you're dealing with any industry, particularly when you mention the word nuclear, is that people have a good understanding of what's going on in their local area. And the liaison committee enables this to happen. It does allow people to bring questions to the table, and I think that does help to alleviate fears. My litmus test of these things is the number of people that have knocking on my door that are expressing concerns about the industry, and I have to say, over my period of representation on the committee, there's been very, very few indeed.
Because of the exceptional care, professionalism and attention to detail applied by PNTL to its shipments and the nuclear companies behind them, the transportation of nuclear cargoes between Europe and Japan is carried out safely, securely and reliably. With nearly 40 years of safe operation and a proud record of pioneering maritime standards for shipping nuclear material, PNTL's vessels provide an essential link in meeting today's demands for secure, efficient and sustainable energy. The MOX fuel they transport ensures that people can enjoy all the day-to-day benefits of electricity, with all the benefits of recycling and clean air.